Okay, so I've got three cables, B, C, and D, given magnitudes up there, and I want to add them together and find the resultant force A. So again, I'm going to write each force in Cartesian form. I'm going to do that by taking the magnitude of the force times the position vector going from A to B divided by the magnitude of that position vector from A to B. So I'm going to take, again, that's going to be 520 times going from A to B. In the x direction is 0, in the y direction is negative 10j, and in the z direction is negative 24 in the k direction. And that's going to be divided by 10 squared plus 24 squared. So this is just really only in two directions here. It's in that YZ plane as shown there. And in doing that, I find that I get negative 200J minus 480K. Again, taking that 520 times 10, and I believe is it 25? 10 over, no, 26, 10 over 26, and then 520 times 24 over 26 to get the 200 and the 480. All right, so doing the same thing for FC this time. Okay, I'm going to take the 680 and take it times the XYZ going from A to C. So in the X direction, I go 16. In the Y direction, I go 18. And in the Z direction, I go down 24. And that's going to be divided by 16 squared plus 18 squared plus 24 squared. Okay? And again, taking 680 times 16 over that magnitude gives me the I and then the J, K. I'll let you do that on your own. I get 320I plus 360J minus 480K. Do the same thing in the D direction. I'm going to take the magnitude, which is 560. I need the position vector going from A to D. This time in the X direction, I go negative 12. In the Y direction, I go positive 8. And then I do the negative 24 in the K direction, minus 24 in the K direction. Take it times its magnitude, 12 squared plus 8 squared plus 24 squared. Okay, so again, take 560 over that magnitude, that square root there, take it times negative 12i times 8j times negative 24k, and I get negative 240i plus 160j minus 480k. Adding up x, y's, and z's, right? So I get 0 plus 320 minus 240 gives me 80i. So my resultant force is 80i. In the j direction, I have 200, 360, 160, negative 200, I should say. That gives me 320 in the j. And in the k direction, it's negative 480, 480, 480. So negative 1440 in the k direction. Okay? To find the resultant, I just take, or the magnitude of that resultant, I just take square root of the sum of the squares. I'll let you do that on your own, and you get the answer 1477 newtons. So write each force in Cartesian form by taking the magnitude of the force times the position vector divided by its magnitude, add up the x's, y's, and z's, and get your resultant force.